Hi everyone. In the today's session, I want to discuss about the project management. So, what is project management? So, let us discuss about that. So, first of all, we need to know what is meant by a project. So, a project means it consists of interrelated activities which are to be executed in a certain order before the entire task is completed. So, we are making the project as a task, the work we need to complete. So, that task is divided into a number of sub activities, and those all of activities are interrelated, and if you execute those activities in a certain order, then the entire task will be completed. See here, the activities are interrelated in a logical sequence which is known as precedence relationship. So, whenever the activities are interrelated with a logical sequence, it is known as precedence relationship. So, in order to make the management of a project, first of all, we need to represent the project in a network form. So, here the project is represented in the form of a network for the purpose of analytical treatment to get solutions for scheduling and controlling its activities. So, in a network, if you take, that network consists of set of arcs which are connected meaningfully through a set of nodes. And if you see this network diagram, so here it is, I am showing one of the project to you. So this is the one of the project, and this project was shown in the form of a network diagram. So in this network diagram, this is one activity, this is another activity. So these all activities are interrelated in a logical sequence. So here the activity G is connected to A. So that's why these two connection is known as a precedence relationship. It is known as precedence relationship. So like that, if you take a network, it consists of arcs which are connected meaningfully through a set of nodes. The activity is represented in the form of an arc, and this activity is connected to another one with the help of the nodes. So these are called, the round circles are called nodes. So with the help of nodes only we are connecting the activities in a meaningful way. So that is about the project, and the precedence relationship among various activities of a project can be conveniently represented using a network. So this was already we discussed. Here all the activities are connected in a meaningful way, and that is we are calling it as precedence relationship. So here the method of representing a project in a network form can be of two types. One is activities on arrows, that is AOA diagram. Next, activities on nodes diagram. AOA and AON diagrams, we can represent the project in the form of a network. So here the AOA, activities on arrows diagram, is the preferable one in order to represent the project in the form of a network. So this is the most widely used diagram for the representation of a project in the network form, right? So if you take the project management can be divided into three steps. So one is planning, another one is scheduling, and next one is controlling. So suppose if you take a project, so that means the manufacturing of a machine component, or suppose if you want to manufacture or if you want to construct a room. So if you want to construct a room, So the first task we need to do is we need to create the holes for the foundation, and then we need to establish the pillars, and then the slab has to be made, and finally the walls has to be constructed, and next we need to do the provide the electrical wiring, and then finally we will do the whitewash of the room. So like this, in this sequential way, we are the activities for that construction of a room is divided. So these all activities have to be planned, scheduled and controlled. That total thing we are calling it as a project management. So the construction of a room we are taking it as a project, and the managerial of activities of for constructing the room is known as project management. So in the project management, how we are going to divide the project management means in a three parts: planning, scheduling, controlling. So first of all, let us discuss about the planning, what we are going to do in the planning. So in the planning of project management, here we are dividing the project into distinct activities, and next estimating time requirement for each activity. That means how much time it will take in order to complete that activity. Establishing precedence relationships among the activities. Precedence relationship means the next activity, if you want to continue the next activity, the previous activity should be completed must and should. So like that, we need to establish the precedence relationship in between the activities. And the last one is construction of a arrow diagram. So if we do all these four works, this will come under the planning of project management. So these are all activities we are going to do in the planning. And next one is scheduling. So in scheduling, what we are going to do? So in scheduling determines the start and end times of each and every activity. And the next thing is these can be summarized in the form of a time chart. So these two things we are doing in the scheduling. And third one is control. So in controlling, what we are doing means it uses the arrow diagram and time chart for continuous monitoring and progress reporting. So in the name itself it is there controlling. Here we are going to monitoring and progress reporting of that network diagram. And next, the network will be updated if there is any variation in the proposed schedule. Suppose if the in the planning, if any changes were made, so the immediate updation will be made in the controlling session. So like that, we are going to do the project management in three different phases, right? So if you are going to do any work, or if you want to take any task to complete it, that task we are calling it as a project, and that project is divided into a number of activities, and the activities management we are calling it as project management. So the project management technically we can divide into three subgroups: one is planning, scheduling and controlling. And what we are doing in these three stages, those are all discussion now, right? So now for the representation of a project, we are using a network diagram, and that network diagram is going to be constructed in a AOA form or by using the AOA methodology. So before constructing a network diagram, what is the terminology we are going to use? So that thing, first of all, let us discuss about that. So this one is the terminology which we are going to use in the network diagram. So here it is an example network diagram. I am showing it to you. So network diagram is, it is nothing but a project. The project is diagrammatically represented in the form of a network, right? So now let us discuss about the terminology what we are going to use in the network diagram. So the first terminology we are going to use is node. Node means generally a node represents the starting and ending of an activity. So here if you see the network diagram, A, B, C, D, E, F, G, H, I, J, K, L, M. These are all called activities. So each and every activity is representing the starting and ending of an ending node. So if you take the activity A, so the starting node is 1, ending node is 2. So this is known as tail node and this one is known as heading node. Tailing node, heading node, right? So each and every activity will have a tailing node and heading node will be there. And next one, the next term we are going to use is the branch or arc. So a branch represents the actual activity which consumes some kind of resource. So here we need to complete if you want to complete a task, we are dividing the each and every task into a sub number of activities. So these are the sub number of activities. So the activities are represented in the form of a arc or branch. So this line will represent the arc. So if we draw a arc means an activity is going to be processed by using the some of the resources at that place. So that is known as branch or activity or arc of activity. And next third one is precedence relations of activities. So here what we are doing means for any activity the precedence relations provide the information about the activities that precede it, the activities that follow it and the activities that may be current with it. So that means if we want to complete the activity G or if we want to do the activity G here, must and should the activity A should be completed. After the activity A only we can able to go for activity G. So like that the we can say that the activity A is the precedence relationship for activity G. So like that we are going to use that term for constructing of a network diagram, and these three are the terms we are going to use in the network diagram, right? So now let us see the next one, that is guidelines for network construction. So what are the guidelines to be followed for constructing a network diagram? Let us see. Okay, so the first guideline is the starting event and ending event of an activity are called tail event and head event. So this one has already I have discussed. So if you see this network diagram, so this one we are calling it as tailing node, or this one we are calling it as heading node or event. So దీన్ని ఈవెంట్స్ అని అంటాం, వీటిని దీన్ని టైలింగ్ ఈవెంట్ అంటాం, దీన్ని హెడ్డింగ్ ఈవెంట్ అని అంటాం. ఓకే, రైట్. The network should have a unique starting node. So if you see this network, in this network the unique starting node is 1. So from 1 only the network diagram is going to start, right? And next one, the network should have a unique completion node. So the project is going to be end at a node. So if you take that 12, it is the unique completion node. 1 is the unique starting node and 12 is the unique completion node. And next one, no activity should be represented by more than one arc in the network. So if you take the activities A, B, C, D, E, F, G, H, I, J, K, L, M. So in these activities are represented only by a single arrow. So here A is represented only by a single line, B is represented only by a single line, not by a double line. So this is one of the guideline in order to construct a network diagram. Next, no two activities have the same starting node and the same ending node. So if you take the activities G and B, so the activity G starting node is 2, ending node is 8. If you take the activity B, starting node is 2, ending node is 5. So that means activities B and G will have the different ending nodes but same starting node. But what we are saying, no activity should have same starting node and same ending node. So here B and G have the only same starting node, but different ending nodes are there. So the condition was satisfied. And next one is dummy activity is an imaginary activity indicating precedence relationship only. Duration of the dummy activity, we are taking it as 0, right? So here if you see in the network diagram, a arc was represented in the dotted line form, that is 3 to 4 and 5 to 6. So if we draw an arc means here we are not representing any activity. So it is represents only the precedence relationship only, and the duration of this activity we are taking it as zeros. So like this, these guidelines have to be taken into consideration for the construction of a network diagram, right? So like this we are going to represent the project in a network form by following all of these guidelines by using the methodology of arrows on arrows diagram, right? So in order to analyze this network diagram, there are two methods are there. So that is, those are we are calling it as techniques used in project management. So the first technique we are going to use the critical path method, that we are calling it as in a short form CPM, and the next technique is project evaluation and review technique. In the short form we are calling it as PERT. So these two techniques are used for the analysis of a network diagram, right? So now first of all let us see the critical path method, and now we are going to know about the critical path method by solving a problem, right? Here this is the problem I am going to solve by using critical path method. So let us see. Consider table summarizing the details of a project involving 14 activities. So in order to complete a project, that project is divided into 14 activities. So what are those activities? Let us see. So the activity here, the details, project details are represented in the form of a table: activity, immediate predecessor and duration. So here what are the activities means: A, B, C, D, E, F, G, H, I, J, K, L, M, N. So these are all the activities, and for all of these activities the preceder activity is given. So for activity A, B, C, there is no any preceder activity, and for completing the activities A, B, C, the duration was given. For completing the activity A, 2 months of time it will take. For completing the activity B, 6 months of time it will take. For completing the activity C, it will take 4 months of time. So like that, for each and every activity the duration for completing that activity is given, and the immediate predecessor was also given. So now what he is asking us to find? So he is asking us to find three terms. One is construct the CPM network, and next one is determine this critical path and project completion time, and third one compute total floats and free floats for non-critical activities. So these are the three things we need to complete. So what is the first thing we need to do? Construct the CPM network. So the network is going to be constructed by using a methodology of arrows activities on arrows diagram, right? So now without any let us construct the CPM network. Okay, now let us construct the network diagram. So first, if you see the table, the activities A, B, C. So for these three activities there is no any immediate predecessor. So that means those are the starting activities from a node. So now let us represent those three activities from a starting node. So now I am taking a starting node 1. So from node 1, how many activities are starting? So three activities are starting A, B, C. So I am representing all those three activities. Activity A, activity B, activity C. So what is the duration of those activities? For activity A, duration is 2 months, activity B, duration is 6 months, activity C, duration is 4 months. So now let us represent the same things. So 2 months, 6 months and 4 months. Let us take these notes as 2, 3 and 4, right? So now three activities were represented on a network diagram. Next, what is the next activity given? D. So for the activity D, the immediate predecessor is given, that is B. So that means after completion of B only, the activity D has to be started, right? So similarly, let us search in the table any activity is there which is the for which the predecessor is B. So now let us see the activities E, F, G, H. For all of them, whether any activity is the predecessor as B, right? So for E, the predecessor is A. For F, predecessor is A. But for G, the predecessor is B. So like that, let us see. So the predecessors are C, D, E, F, G, H, I, J, K. But the predecessor as B, there is only for two activities, that is D and G. So now let us represent those two activities, D and G. So D and then G. So for D and G, the predecessor activity, the previous activity is B only. So now let us represent the nodes. It is 5, right? Next, activity E. For activity E, the immediate predecessor is A, and for activity G also, F also, the immediate predecessor is A. So now let us represent that one. So for E and F activities, so E activity C6 I am taking, and then F activity I am taking, right? Next, G activity already we represented. Next, for H activity, the immediate preceded is C and D, right? So now let us represent in that way. For H and I, for H activity, the predecessor is C and D. So if you draw a line representing the activity H, the both predecessors are C and D. So C and D are coming in this way. So if you draw a line H, that will represent C and D. So for activity C, what is the predecessors? C and D, right? And next one, for I activity. For activity I also, the immediate predecessor is C comma D. So now let us draw one more arc which is representing I. So I am taking this node as 7, right? I activity node as 7. So for I activity also, the predecessor is nothing but C and D only. And next one is activity J. For activity J, the immediate predecessor is E. So now let us represent the J. So please see, for any activity the producer is E. So E is not producer for any activity. So that's why after E we are drawing only a single line. So this one will represent the activity J. I am taking this node as 8. Next, activity K I am taking. So for activity K, the immediate producer is FGH. So that means FGH we need to represent as producers for the activity K. So here if you see the network diagram, also FGH, these three should meet at a point. So here if you see the activities FGH, these three are meeting at this point 5. So now from this line we need to represent the activity K, right? So if you see the table, the FGH is the immediate producer for the activity L also. So that means we need to draw two lines from the node 5. So this is the first line, it will represent the activity F, and this is the second line I am drawing, this will represent the activity L. So I am taking this one as a node, I am taking this node as 9, right? And next, activity M, the immediate producer is I only. So immediate producer is I only means from this place we are going to draw the activity M, right? That is completed. And what is the last one? He has given activity N. For activity N, the immediate producer is J comma K. So sorry, this one is K activity. So both J and K are coming at the node 8. So that's why from this place I am going to represent the activity N. So this one is the network diagram representing all the activities, right? So without any let us represent the duration of those activities. So the duration of those activities are given in the table, for A 2 months, for B 6 months, for C 4 months. So like that I am going to represent the all the durations for the activities. So for activity E, 6 months of duration, for activity F, 8 months of duration, for activity G, 3 months of duration, for activity D, 3 months of duration, for H activity 7 months, for I activity 2 months, for activity M 13 months, and for activity L 3 months, and for activity K 4 months, J activity 5 months, and N activity 7 months of data was given, and that one I am representing in the network diagram. So now the first bit what he has asked, construction of So now earliest starting time at node 2 is 0 plus 2, so that equals to 2, right? Next, earliest starting time for node 3, only single arrow is incoming, so 0 plus 6, 6. Next, for node 4, what is the earliest starting time? Only one arrow is incoming to that node. Sorry, two arrows are incoming to that node. So, if you take the first arrow, the earliest starting time is 0 plus 4. That means 4. If you take this arrow, the earliest time will be 6 plus 3, 9. So, here it is 4, here it is 9. So, what is the maximum? Here we need to take the maximum. So what is the maximum of earliest starting time? Here it is 0, here it is 6. So maximum is 6. So now take this one. So 6 plus 3. So that is equals to 9. Right? Next one. Let us calculate the earliest starting time for node 5. So for node 5, how many number of incoming arrows are there? 1, 2. So if you take this arrow, the total time will be 6 plus 3, 9. And if you take this arrow, the total time will be 9 plus 7, 16. It is 9, it is 16. What is the maximum value? 16. Right? Next, for node 6, let us calculate. For node 6, only a single arrow is coming, so 2 plus 6, 8. Next, for node 7, let us calculate. So for node 7 also only a single arrow is coming, then 9 plus 2, 11. Next, node 8. So if you take the node 8, the incoming arrows are 2 incoming arrows are there. So if you take the first arrow, the total time will be 8 plus 5, 13. If you take the second arrow, total time will be 16 plus 4, 20. So here it is 13, here it is 20. So the maximum is 20. So we are taking 20 here. Next, if you take the node 9, so if you take the node 9, so for node 9 the incoming arrows are 3, right? So if you take this sum, 20 plus 7, 27. Here if you take this sum, 16 plus 3, 19. If you take this arrow, 11 plus 13, 24. So here it is 27, 19, 24. So what is the maximum value? 27. So the earliest starting time for the node 9 is 27. So like this, we are going to find the earliest starting time at each and every nodes. So similarly, we need to calculate the latest completion time for each and every node. So how to calculate that latest completion time means we are going to use the formula latest completion time is equals to minimum of latest completion time of end activity minus duration of the activity, right? So let us see the latest completion time we are going to calculate from the heading node, that is final node to starting node. So that means from node 9 to we need to move backward. So now what is the latest completion time for node 9? It is nothing but 27 only, right? So now let us calculate the latest completion time for the node 8. So if you take the node 8, so for node 8, what are the arrows coming? N, K. So if you take 27 minus 7, it is 20. And here for this already we did not calculate it. Let us calculate that one. So now for node 7, let us calculate. So for node 7, if you take 27 minus 13, it is equals to, here only one arrow is coming, 27 minus 13, it is equals to 14, right? Next, for node 5, let us calculate. For node 5, it will be 27 minus 3, only a single arrow is going, So 27 minus 3, it is equals to, so before node 5 already the nodes 8 is there, let us calculate it. So 27 minus 7, it is 20, right? So 9, the previous one 8 is completed, previous to 8 7 is completed, so previous to 7 the thing is 6. So now let us calculate the latest completion time for 6. So 20 minus 5, it is equals to 15. Next, what is the previous node to 6? 5. So let us calculate the latest completion time for 5. So that is equals to, so to 5, 2 arrows are coming. So 20 minus 4, 16. 27 minus 3, 24. So in 16 and 24, what is the minimum value? 16. We have to take that one, right? Next, node 4. So this is the node 4. How many lines are coming to node 4? 2 lines are coming. So now take 14 minus 2, 12. 16 minus 7, 9. So which one we need to take? Minimum value. So 16 minus 7, 9 is the minimum value. So latest completion time will be 9. Next, what is the next node for after 4? 3. So what is the, how many arrows are coming to 3? 1, 2 arrows are coming. So if you see the minimum value, 16 minus 3, 13, and 9 minus 3, 6. What is the minimum value in 13 and 6? Minimum is 6 only, so that's why we are writing 6. Okay, so what is the next node? 2. So to node 2, how many lines are coming? 1, 2. So if you calculate the latest completion time through this line, 8 minus 6, 2. And if you calculate through this line, 16 minus 8, 8. So here it will come 8, here it is 2. What is the minimum value? 2 only. So that's why we are going to write 2 here. And next, what is the next node? 1. So to node 1, how many lines are coming? 3 lines. 1, 2, 3. So if you calculate the latest completion time, 2 minus 2, 0. 6 minus 6, 0. 9 minus 4, 5. But what is the minimum value in 0, 0, 5? 0 is the minimum value. So like this we are going to calculate the latest completion time and earliest starting time at each and every node. So for calculating the earliest starting time, we are moving from node 1 to node 9, and for calculating the latest completion time, we are moving from node 9 to 1. So in a reverse way we are going to follow. So now what is the total time taken for the project completion? So the total time completion for latest completion time will be 27 months. So that is the project completion time. So and next we need to calculate the critical path. So what is meant by a critical path? So how to find critical path means, for which activities the earliest starting time and latest finishing times both are equal at the nodes that we are taking as the critical path. So now first if you take node 1, earliest starting time, latest finishing time both are equal. So we need to start from 1. And next, if you take node 3, earliest starting time, latest finishing time both are equal. So we need to take that one. Next, here if you take earliest starting time and earliest finishing time both are equal. So if you see here, the LST is 8 only, right? Why? Because means 15 minus 6, 11. 16 minus 8, 8. In 11 and 8 the minimum value is 8 only, right? So here it is 8. So ES, LS both are equal. ES, LS both are equal. So that's why we need to move in this way. I am representing the critical path by darkening the line. Next, from activity 3, node 3, whether we need to move to 5 or 4. So here if you take ES LS both are equal, so that's why I am moving to 4. Next, from 4 to 5 or from 4 to 7. So ES LS both are equal, but here ES and LS are both are not equal, so that's why I am moving in this way. Next, from 5 to 8 or from 5 to 9. So if you take here ES and LS both are equal, so I can move 5 to 8, not by directly 5 to 9. Next, 8 to 9, as both are equal, I can move to 8 to 9. So now what is the critical path? 1 to 3, next 3 to 4, next 4 to 5, next 5 to 8, and next 8 to 9, right? So by representing the activities, this is B, D, H, K, yeah. So like this we need to identify the critical path. Next, what is the third bit? He asked us to find the total floats and free floats for the non-critical activities. What are the non-critical activities? A, E, J, F, G, C, I, M, L. So for all of these non-critical activities, we need to find the free floats and total floats. So now I am writing a table. Now let us find the total float and free float for the network diagram. Here this is the tabular column I already prepared for each and prepared. So in the tabular column, activity, duration, total float and free float are there. All activities I have represented, and the duration of activities also I represented. First of all, let us calculate the total float. So what is meant by a total float? Total float is nothing but it is the amount of time that the completion of activity can be delayed without affecting the project completion time. So that is known as total float. So how to calculate the total float means total float of an activity it is equals to latest completion time of ending activity minus earliest starting time of the initial activity minus duration of that activity. So let us calculate for the first activity. So the first activity is 1 to 2. So for 1 to 2 activity, what is the duration? 2 months. So this one will represent the Dij. So if you in the network diagram 1 to 2 activity, what is the latest completion time? So latest completion time of an ending activity. So here our ending node. So for activity 1 to 2, the ending J represents the ending node, I represents the starting node. So latest completion time of ending node. So in the activity 1 to 2, ending node is 2. That is the latest completion time 8. So 8 minus earliest starting time of starting node. What is the starting node? 1. What is the earliest starting time? 0. So 8 minus 0 minus duration of the activity. What is the duration of the activity? 2. So 8 minus 0 minus 2. So then how much we will get? Total float as 6. Right? So similarly, I am taking the activity 1 2 3. So for 1 2 3, let us calculate the total float. So total float will be, so for activity 1 2 3, what is the latest completion time of the ending node? 6. Earliest starting time of the starting node? 0. Duration of that. So 6 minus 0 minus 6. So it will be equals to 0. So like this, I am going to find the total float for all the activities. Here I calculated the total floats for all the activities by using this formula. Total float is equals to LCJ minus ESI minus Dij. So by using the total floats also we can able to calculate the critical path. So how to find means, now take the total float value as 0 activities. So here this activity is 0, so 1 2 3, next 0 is here 3 to 4, next 0 is here 5 to 8, next 0 is here 4 to 5, next 0 is here, that is 8 to 9. Now if you see all of these 1 2 3 and next 3 to 4, next 4 to 5, next 5 to 8, next 8 to 9. So it is the same as the previous one, we found the critical path. So like this, by using the total float also we can able to find the critical path of a network diagram. So now let us calculate the free floats. So how to calculate the free float? So free float is equals to earliest starting time of the ending node minus earliest starting time of the starting node minus duration of the activity. So now I am taking the activity 1 to 2. Let us find the free float for that. So what is the activity 1 to 2? So the earliest starting time of ending activity 2, earliest starting time of starting node 0 minus duration of this. So 2 minus 0 minus 2, so that one we will get as 0. Next, if you take the activity 3 1 2 3, then earliest starting time of ending at node 6, earliest starting time of starting node 0 minus duration of act. So 6 minus 0 minus 6, so then you will get 0. So first of all, what is meant by a free float? It is the amount of time that an activity completion time can be delayed without affecting the earliest starting time of immediate predecessor, immediate successor activities. So that is known as free float. So that free float can be calculated by using this formula. So now let us find the free float for all of these activities using that formula. Here if you see, here I have calculated all the free floats for each and every activity. So like this, by using those total float and free float formulas, we can able to find the all the values, and by utilizing the total float values we can identify the critical path also. So now whatever the 3 bits asked us in the problem we have completed. First of all, he asked to construct a network diagram, we completed, and then he asked us to find the critical path. So we have find out the critical path, and next the project completion time 27 months we calculated, and also he asked us to calculate the total float and free float. So like this we can analyze the project of a network of a project by using critical path method. So I hope you understand this problem and this critical path method. So if you like, please subscribe to the channel and share this video. Thank you.